Okay, so we are going to try to solve this problem 232 from Griffiths, third edition. What is the idea? We have here in red this finite well potential, and the energy is in blue. The energy is here in blue above the potential. So all these three regions that I marked here, region 1, region 2, region 3, they are all allowed classically. We went through Schrödinger's equation, the time-independent Schrödinger's equation, solved it, and used boundary conditions. Boundary conditions here at x minus a at this point, and we found these two equations. So in the book, this equation here is 2.1666, and using the derivative, no? So this equation came from the continuity of Schrödinger's the wave function, and here from the derivative, the continuity of the derivative, and this is 2.167. Okay, so this is boundary conditions and minus a. Using boundary conditions at a, here, we obtain these two other equations. Okay, what is it that we want to do now? We want to find the transmission coefficient. So remember, the transmission coefficient is this f squared divided by this a squared. What does f and a mean? We know a is related to the portion, well, is related to the whole wave function that is transmitted to the right. And f is related to the portion that passes through that well and keeps going to the right. Okay, so the transmission coefficient is then the absolute value square of f, that amplitude that was transmitted, divided by a, which is the part that, the whole thing that came from minus infinity. Okay, so this is our goal. All right, so how are we going to proceed? To find this, we will need to find a way to write f only in terms of a. Okay, so we need to get rid of this b, this c, and this d. So all of the things that are on our way. So how are we going to do this? Well, we are going to start from these equations here on the right side. So we are going to manipulate these equations here. And we are going to add one by the other, multiply them. So we are going to manipulate these equations so that we find two new equations. One equation will only have c in terms of f. So we'll have to get rid of d. The other equation that we want to build out of those two will have just d in terms of f. So we'll need to get rid of c. So that's the idea. What for? Then with these two new equations, we are going to come back to the left side. We are going to come back to the left side, and instead of c, we are going to use this part. So instead of c, we are going to find a way to write it in terms of f. In terms of, instead of d, we are going to write it in terms of f using what we found here. Same thing at the bottom equation. So this c, we are going to write in terms of f, and this d also in terms of f. So you see that once we do that, we now have two equations, a, b equal to something f, a, b equal to something f. And now we are going to manipulate these two equations here to get rid of b. Yeah? So once we do that, finally, we'll have f in terms of a, and that's great, because then we can then find our transmission coefficient like this. You see, that's the idea, but the procedure, yes, it's a long procedure, so we have to be patient. Very good. So let's start with those two equations that we have on the right. Okay, so let's start with these two equations here, and I'm already going to start manipulating them for the first purpose, which is to get rid of D. Okay, to get rid of D, here on the top, we have D multiplied by cosine. At the bottom, we have D multiplied by sine. So how can I get rid of that? Here comes our idea. We are going to, the first equation, the top one, we have C sine LA. I'm going to multiply this equation by the sine, because here I now have D cosine and sine, and on the right, FIKA with the sine. Okay, so I multiplied this equation, this whole equation by sine. So that's why this sine now is square. Here I have cosine and sine. Now at the bottom, I'm going to, there is C, I'm going to multiply it by cosine, so that's why here it's squared. Then we have D, I multiplied it by cosine, so the cosine appears. Sine L over A. And you may say, hey, wait a second. What do you do with this L? I'm going to pass it to the right side. I'm going to pass it to the right side, so I have IK over L, F, IK, and remember, we multiplied everything by cosine, right? So I have to remember to put this cosine here as well. Aha! So what do you see now? If I look at these two equations, if I add them, I get rid of the D as we wanted. Okay, perfect. So we have to isolate, and now we have, now, and even better, now if you look at the sum of these two, cosine square plus sine square is 1. So beautiful. We arrive at this C equal to, and the F on the other side, which is what we wanted. Now, so we have C is equal to F IKA, which is in both terms, and then we have sine LA, and what else? We have this IK over L and the cosine. All right, so let's keep this. We'll need it later to go to, no, we'll need it later to come back to this. So you see, we are done with this first part. So let me mark here. We did this. Now we want to do the same game, but to isolate D, to write D in terms of F. So D in terms of F, get rid of C. Well, let's see what we are going to do. I have good memory. I have it written somewhere, okay? So I will remember what we have here. So it's C sine of LA, D cosine of LA. So let's write it here. The other two, C sine of LA. Now we want to get rid of the C part. So I'm going to multiply this by cosine of LA. Okay, so D, remember D was cosine, so this is going to become squared, equals to FIK, and now it's cosine on this side. Okay, at the bottom we have C. Now I'm going to multiply the cosine by sine. So there was already cosine, so now I multiply by sine. And then here we have minus D. Okay, I'm going to keep it and then we'll talk about. So it's minus D with sine. So this becomes sine square. IK, FIK, sine of LA. And remember, there was L here, which I'm going to pass to the right. Okay, so here I put this L below. All right, so these two also look very good, except for a sine, because I want to get rid of the C. So to get rid of the C, I'm going to multiply the equation here at the bottom by a minus. So minus. Okay, so now we got rid of C. when I sum these two. Cosine square, again, cosine square plus sine square is 1, so perfect. We got that D is equal to FIKA, and then what we have inside? Cosine of LA minus IK divided by L, and then the sine. All right, excellent. We did what we wanted. This second part here, we did. Now, so we now have C written only in terms of F, D written only in terms of F. Now we are going to come back to these equations here, and wherever there is C, we are going to use this. Wherever there is D, we are going to use this. All right, so let's go. Very patient. Let's start. So the first equation that we have here is this one. Oh, we have A exponential of minus IKA plus B IKA, and now comes the minus C will become this whole thing here. So equal to minus, now the C is FIKA sine LA plus IK over L cosine of LA. So what I wrote here is this. But in addition, we have C multiplied by this sign, so I cannot forget to put this sign there. Okay, good. The next part is this D here. So I'm going to copy this whole thing. So here I have plus F exponential of IKA, and then we have cosine LA minus IK over L sine LA. And remember, this was multiplied by cosine LA. Good. So let's try to manipulate these things a little bit. Let's see what we can simplify. Look at this. Cosine with this cosine will become cosine square. Sine with this sine will become sine square. So this looks good. And here we have cosine and sine, cosine and sine. Well, this is good. We'll probably be able to play with some trigonometric expression. So let's see. Let's rewrite everything. So what do we have in common for these two, both terms? F exponential of IKA. No? And then I'm going to start from the bottom, from this part here, okay, with the positive part. So we have there cosine square of LA. In addition, we have minus IK over L, cosine and sine. Let's write as like this, sine and cosine. Good. Now I go for this top. In this top, careful, we have a minus sign there. So we have minus sine square. And we also have minus, I'm going to put it here, minus IK over L sine and cosine. Okay. Okay, so look. When we have cosine square of something minus sine square of something, we can rewrite this as cosine of 2 something, in this case theta. Okay, so this is what we have here, cosine minus sine. So we are going to write that as cosine of 2LA. All right, then these two terms are equal. no? So we have it twice. But if you remember relations in trigonometry, you may remember the sine of 2 theta is cosine theta sine theta plus cosine theta sine theta. So 2 cosine theta sine theta. Okay, so what we have here is now, let me just put this IK over L. So this is just going to be sine of 2LA. All right. So we got our new equation that has only A and B and F. No? So we got rid of C and D. That's what we wanted. In one of the equations, let's do the same now for this this second equation here. Okay, so we are going to do the same trick. Substitute C and D there. Okay, so this equation starts with an I and K. You see here there is I and K, and here there is L. So I'm going to put this I and K here, L divided by this I and K, okay? All right, so then we have A minus IK, and then we have minus B, AIK. Remember that on this side we have L, and I said that I'm going to bring this IK, but I can put this I in the numerator by changing signs, right? So I'm going to get it out of here and change signs, putting it on top. Okay, and then this term, I will have again, same story. Wherever there is C, I'll write it in terms of F. Wherever there is D, I'll put it in terms of F. So let's go again, patience with this. And then we go. F, IK, IKA, and then we have the first term is C, and C is this guy. So then we have sine of LA plus IK over L cosine of LA, good. This is now multiplied by cosine of LA, okay? Then we have again the same thing. I'm going to put this like this. So again, plus FIKA. So what I'm doing now is this one, so plus, and now the equation for D. And the equation for D is this one. Okay, so inside here, we have cosine of LA minus IK over L sine of LA, and this is all multiplied by sine of LA. Great. All right. Well, now again, let's try to simplify these things, okay? Just as we did above. So minus IL over K F exponential of IKA. Now let's open the whole thing. Inside we have sine and cosine. We have plus IK over L cosine square. We now have from this equation, from the bottom, we have plus sine and cosine. You see that this and this are equal. And then we have this last term, So it's going to be minus ik over L sine square. So again, we are going to use trigonometry. And so how are we going to simplify these things? Minus IL over K, F IKA, and then the one that I marked here in red is going to be sine of 2, whatever we have there. No? So it's going to be sine of 2LA. Now the other term is cosine square minus sine square. So this one here is cosine square minus sine square. So this is the cosine of 2. So we have plus IKL cosine of 2LA. Okay. Let's see if we can simplify things a little bit more. Well, let's try to keep in front just the term that depends on f and the exponential. Okay, so we are going to put inside this piece. Okay, so you see that if we put this piece inside, minus I, remember, minus I with plus I will give us plus. Okay, so I'm going to start with this cosine, and you see the L cancels, K cancel, so what survives here is just the cosine of 2LA. Okay, and then, well, this whole thing multiplied by this sign, I just copy the whole thing, IL over K sine 2LA. All right, so we found, okay, so we now have two equations, this one and this one. So there is only, in our equation, there are only A, B, and F. So let me write these two equations together, which will make things easier to see. So the first equation that we got is this. AI minus IKA plus B exponential of IKA, and this is equal to F IKA, and inside we have cosine 2LA and minus IK over L sine of 2LA. Good. So this was the first one that we got. Now the second one is this. Is this one the last one? Okay. So this is going to be A exponential of minus IKA. Now comes minus sign. So this is excellent that this minus sign is already appearing because we want to get rid of this B term. Remember, we just want to have F and A. And then on the right side, we have that F, IKA, and inside we had the cosine of 2LA. See how similar everything became at the end, no? After all these manipulations. And here we have minus IL over K sine of 2LA. Okay, so we ended up with these two. And what we want to do, we want to get rid of B. So I'm going to sum both. And then we get what we wanted. What we have now, 2A exponential is equal to, let's put everything that is related with the F. So we have 2 times the cosine. And then we have 2 terms with I. So I'm going to put the I in front, and then we have K over L, and we have plus L over K. All that multiplied by the sign. And that's it. Now, so we did the hardest part. Now what we can do is isolate this F. Now remember what we want to do later is to find the transmission coefficient. So that's what we want to do. So I'm going to isolate it F. And F then is equal to Let's see things that we can simplify some things here, because I see that there is number 2 here, there is number 2 here, and in the last one we don't, but we can divide it by 2. Okay, so I'm going to multiply and divide by 2. Okay, so then we have, so then you see that I can get rid of these 2. And so we have that f is equal to exponential of minus 2 IKA. Now, because this is minus, and when I pass this one to this side, it also becomes minus. And A, now this whole term here is going to come to the denominator. So we have here cosine of 2LA. This is a long term, so let me make it bigger here. And then we have minus I. We can do the following. We can put everything divided by the common denominator, LK, and there is number 2 as well. And then we have K squared plus L squared, okay? And sine of 2LA. All right, so this is what we wanted. Now, with this, we are done. Now we can just find the transmission coefficient by doing absolute value of f squared divided by absolute value of a squared. When we do absolute value of f squared, this term here disappears. Now it becomes 1. And then the term in the denominator, since this part is real and this has the imaginary part, I have just the square of the real and the square of the imaginary part. So this transmission coefficient will be 1 over cosine square of LA plus K square plus L square divided by 4 L square, there is a square here, L square K square sine square of 2LA. Okay, so this is where we wanted to arrive. Well, almost the end of the story, because now it's a matter of playing with it's algebra. Okay, what you need to do is substitute what K and L are in terms of energy. And so remember, K square is 2me over h bar square. So you have to substitute this in your equation. And L square is 2me plus v naught divided by h bar square. So you have to put all this on this equation, and you will finally find the equation that is in your book, the equation for the transmission coefficient, which is 2.172. Okay, so I think this is enough. Very good. So we can stop the recording.